Hello and Namaste. In continuation with the double integrals, we are going ahead with the over a general region, and this is a part 3. After the part 1 and part 2 in detail, we are dealing here with a little different type of questions which we have not dealt with the part 1 and 2. Now evaluate double integral xy dx dy over the region enclosed by the x-axis, the line x is equals to 2a and the parabola x square is equals to 4ay. That means from this particular question we have to take care of x-axis, x is equals to 2a line and the parabola. So these are the three different figures have been given to us in this particular question. Now first is x-axis. X-axis is nothing but y is equals to 0 as the equation of this x-axis. X is equals to 2a is the line parallel to y-axis and passing through the x is equals to 2a point. Then the x square is equals to 4ay is nothing but the parabola which is symmetric to y-axis. These are the figures we have to go ahead. Now after we before going ahead and drawing all of them in the graph, before we have to go ahead with the point of intersection. What would be the point of intersection whenever we, so this is like the checkpoint for us whenever we are drawing the different curves in the figure. We have to have the point of intersection known of those curves in beforehand so that we can draw them exactly. Now point of intersection, we have to take care of the point of intersection of these two curves, x square equals to 4ay and x is equals to 2a line. Now if you'll observe here, x square is equals to 4ay and x is equals to 2a. If I'll put this value, the value of x in this equation, that will gives us 2a the whole square is equals to 4ay. That means it's nothing but 4a square is equals to 4ay. So 4a and this a will go off and we will remain here with y is equals to a as the intersection or interception or the value of y. That means we will have the point or these two curves will intersect at the point 2a comma small a. These are the point of intersection of these two curves. That means what? This is this type of figure we need to draw it up. This is the parabola x square is equals to 4ay. This is the line x is equals to 2a. This is the axis or y is equals to 0, that means the x-axis over here, and the curve or if you observe here, this is the point of intersection. We have drawn it from these two curves like a parabola and a line. X is equals to 2a, that is 2a comma a. So this is the point of intersection. So exactly we can have the little idea about this particular curve. Now the question is evaluate this integral over the region. So what that region would be the region wherein all of them are coming together. Like y is equals to 0 is the x-axis, x is equals to 2a is the line, and x square is equals to 4ay is the parabola. So this is the region which we can go ahead and get it. So therefore y, the limit of y, because we have a choice of taking whether it's a strip parallel to y-axis or a strip parallel to x-axis. So we have taken here the strip parallel to y-axis. So AB is a strip. Now in this case AB, the A point or this particular A point is lying on the line y is equals to 0 to the point B point is lying on the curve x square equals to 4ay. That means we are getting it here y is equals to x square upon 4a. So this limit of y is moving from 0 to x square upon 4a, and the limit of x, if you observe here, this is the origin is 0 comma 0. So the movement of this particular strip from this origin to the point this P would be from 0 to 2a, and therefore x is moving from 0 to 2a, and therefore we will be having this particular I or this particular integral. We can rewrite it as, along with the limits, internal or innermost integral is with respect to y, because here we have taken a strip parallel to y-axis. So y is moving from 0 to x square upon 4a, x is moving from 0 to 2a of the function xy dy dx. Now we have left it now with the simple integration or double integration of this particular function. Moving ahead, this is the integral we need to find it out. Now if you observe here, this inner integral is for y is equals to, so we have to first integrate this with respect to y. Out of this x and y, x is a constant, so we have taken that x outside this second integral or the innermost integral, and we have to integrate this. This is just a simple integral now we have left with. Y square by 2 is the integration of y with respect to y, and the limit is moving. So this is the limit we are putting it as y. So y equals to 0 to this function, and if you observe here, this is 0 to 2a x into this. If you observe the upper limit minus the lower limit, we'll be getting it as x to the power 4 upon 32a square dx. Please do pause the video here. Pause the video and try to get this answer. Similarly, this is just an evaluation of the integral or a double integral, so we can easily move ahead and move fast, and we will get the answer as a to the power 4 upon 3 as the answer for this particular question given to us. Moving ahead with the next question, evaluate double integral xy dx dy over the region enclosed by the circle and the parabola and the line. So if you observe here, we have to take care of the circle, we have to take care of the parabola and the line. So if you observe here, the first is the circle, x square plus y square minus 2x is equals to 0. If we'll go ahead and complete the perfect square like this, so that is x minus a the whole square plus y minus b the whole square is equals to r square, which is a standard equation of the circle in the Cartesian coordinates. We can easily complete the perfect square of this. So x square minus 2x plus 1, so plus 1 we have taken the third term. Similarly, if you have taken something in, we have to give it back, so it's minus 1 over here. And if you observe here, this can be written as x minus 1 the whole square plus y minus 0 the whole square is equals to 1. So we have taken this minus 1 to the other side, that is plus 1 here, and this is giving us, it's a circle with the center at 1 comma 0. If you observe here, this is the a and this is the b over here. So 1 comma 0 is the center and the radius is equals to 1. Similarly, next is parabola, y square equals to 2x, which is a parabola symmetric to x axis, and y is equals to x is the line passing through the origin. Again, the point of intersection. Now point of intersection, we have to take care of all these three curves. First curve is x square plus y square minus 2x is equals to 0 and the line. How this particular two curves will interact with each other and at what point, that we have to take care of. So if you observe this y is equals to x, this is nothing but x squared plus x squared minus 2x is equals to 0. So that means whenever this is nothing but 2x squared minus 2x is equals to 0, that is, if you observe here, in fact 2x will come out and we will have it x minus 1 is equals to 0. So we have got 2 points in the point of intersection here. One is x is equals to 0 and another is x is equals to 1. So that means when we have got y is equals to x sorry, we have got y is equals to x, that time x is 0 and x is equals to 1. That means we have got the point 0 comma 0 and 1 comma 1 as the point of intersection for these two curves. Similarly, if you observe this circle and the parabola, if you observe here, it's x squared plus y square, we are getting replaced as 2x minus 2x is equals to 0. So we'll be getting it here, x square is equals to 0. That means we are going to get it, this 2x minus 2x. So this is x square is equals to 0, x is equals to 0. So that means at this particular, these two curves will intersect at x is equals to 0. If we put x is equals to 0, obviously we are going to get the y value of the y is equals to 0. That means the origin is one of the value or one of the intersection point of these two curves. Similarly, if we move ahead with the third curve, that means we have to have the interaction with each and every curve with each and every other curve. So y square is equals to 2x, y is equals to x. If we observe this particular two curves, we can easily check that x square is equals to 2x. That means x square minus 2x is equals to 0. X is out. X minus 2 is equals to 0. This gives us x is equals to 0 or x is equals to 2. And if you observe, this is nothing but when x is equals to 0, that y is also 0. Similarly, x is 2, y is also 2. So we have got the point 0 comma 0 and 2 comma 2. These are the two intersection points for these two curves. So we have to combine all of them and we need to draw the curve. So if you observe here, this type of curve we are going to get it. Circle, the line and the parabola. So if you observe here, this is the point wherein the point is the parabola and the line y is equals to x is intersecting. So that is a 2 comma 2. We are always getting two different points over here. We will be getting 2 comma 2 is one of the point. Another point for the circle and the parabola would be this, which is 1 comma 1 if you observe here. Similarly, the other point we have got it here for the other thing also. So this is this type of figure we are going to get it. Now the region, so if you observe here, we can have any of the region. We can have the strip parallel to x-axis or a strip parallel to y-axis. But if we take the strip parallel to y-axis, because the limit will be easy for us because it's a parabola. So we are keeping the strip parallel to y-axis. If we are taking the strip parallel to y-axis, So we have to have this, the region OPR. So this is OPR. So the region bounded in the blue color, that is the region OPR. And similarly the other region is RPQ, which is the region bounded with the, or colored with the pink color. So it's a PRQ is the region. And this particular region is getting divided, or this entire one region is getting divided into two because of this point P. It is shifting, the strip is shifting, the lower end of the strip is shifting from the circle to a line after the point P, and that's the reason it is getting divided into two different subsections. So subregion OPR is nothing but wherein the lower end is on the circle, that is square root of 2x minus x squared to square root of 2x, because of the upper end is on the parabola, lower end is on the circle. According to that, we have to change this particular equation. Y is equals to, similarly x is moving from, so if you observe here, this is the origin 0, 0, 0, 0 till this point P, which is, so if you observe the x coordinate of this is 0 to 1. So this x is moving from 0 to 1, and therefore this I1, or the region, or you can say this particular integral becomes in the first region 0 to 1, and then square root of 2x minus x squared to square root of 2x, the same function xy dy dx. Similarly, the sub-region RPQ, if you observe, the lower end is on the line y is equals to x, upper end is on the parabola, same as that. Therefore, the limit of y is moving from x to square root of 2x, and it is moving from the point. So it is moving, the horizontal movement will happen from this P to the point Q. And if you observe, P is 1, 1, it is 1, 1, and Q point is 2, 2. So the x will move from 1 to 2, and therefore this x is moving from 1 to 2, and this is what is I2, we are going to get it. Integration from 1 to 2, integration from x to square root of 2x, xy dy dx. Now this is, we have done it with the identification of all the limits. Now we have left with the integration part. Integration part is very simple, what we have done it so far, evaluation kind of thing. I'm just going to scroll this up so that you can get it, because it's a very simple integrals, you can easily get those integrals very well. And because of the y square factor over here, and this square root of 2x will go up from here, and we will remain here with the simple integration type. And then getting the integration of this with respect to x is also very simple. I'm not going into detail with the evaluation part. Please do pause the video and try to get the answer on your own on this, whatever the answer I've got it on the screen. So the final answer we are going to get it 7/12. This is the answer. I'm keeping it on the screen so that you can just scroll it and pause the video here after this and try to get the answer 7/12 of this double integral, so that you will get definitely a practice of this. And this is the self-observation slide, which is a favorite of mine. The evaluation of two different questions has been given along with the answers. Please do solve the examples. If at all any doubt, any queries, write me in the comment section. And thank you. Happy learning.